So hello everyone, my name is Michal Bentkowski, and today I am going to show you some magic of XSS. You can know me from Twitter. My handle is SecurityMB, and I work for the Polish pentesting company that is called Securitum. If you have any questions, please ask them via the Inventory app. This is because I have some hearing problems, so we might have some communication problems, and when you write the question down, then there is no doubt what you wanted to ask. So what kind of magic of XSS I'd like to show you? Well, basically, when we talk about XSS, about cross-site scripting, we talk about a vulnerability that is typically found in web application. Here you have the definition of XSS from Wikipedia, and you can see that it says here that it is typically found in web applications. And usually, when we speak about XSSs, we mean web apps. However, so this is a typical example of XSS. It is that you have a parameter in URL that accepts some kinds of HTML, and then this HTML is reflected in the response. This is the most typical example of XSS. You are able to inject arbitrary HTML tags, and hence you are able to inject arbitrary JavaScript. It doesn't work always this way, but this is the most simple example. And in today's world, there is a very popular framework that is called Electron, with which you are able to write applications, the desktop applications, using the same technologies that you normally use in web. So for instance, you can write a desktop application using HTML, JavaScript, and CSS. And some time ago, I was analyzing the security of application that is called Hangouts Chat. And this is an application that you can use both as a web application and as a desktop application. So you can download Hangouts Chat and get started right away. So when you use the application as a web application, then it works in the domain chat.google.com. And you can see how it looks like. And then I will try to open the chat desktop application. And on the left, we can see the web application. On the right, we can see the desktop app. And as you can see, there are no many differences between these two apps. Actually, they look exactly the same. And if you have proxy turned on, and you can see what kind of HTTP requests are being generated by the desktop application, then you can see that these are exactly the same requests that the web application generates. So what is the most important difference between these two? The difference is that in case of web application, we have the address bar. And the address bar is actually the only reliable security indicator to tell if we can trust this application or not. We can see if it uses HTTPS, and we can see the name of the domain. We cannot see the same things in the case of the desktop application. So we can trust that the creator of the application made it well, so that you are not able to redirect user to other domain. Because there's no way for you to verify if in the right example you are actually in chat.google.com domain or some other domain. So I have an idea. Because the desktop application doesn't show the address bar, maybe I will be able to redirect the user to a malicious domain, and the user will have no way to notice. He will have no idea that he is on the malicious domain. So I started to test it, and the most simple example was that I can just write down a URL in the chat. So maybe if I click on that link, it will get open in the application Hangouts Chat. However, as you can see, the link got actually open in a browser. This is the Chrome that was run in the background. That would be too easy to work, but sometimes it is worth to check the most easy things, because sometimes they work. Okay, however, I noticed one interesting thing, is that if I enter a link to chat.google.com domain, and then I press that link, it is not opened in the external browser. So links within the chat.google.com domain are open in the desktop application. This is quite interesting, and it will be useful later. I also noticed one quite funny thing, is that if I go to the address of chat.google.com /webchannel/events, this is some special kind of URL in that domain. Then when I click it, I go to the page with an error, 400, and there is no way to go back. There is no back button. You cannot go back with any keyboard shortcuts. So you just have to turn off the application and turn it on again because you are not able to go back to the chat. That was quite funny. OK, so I will open the app again because I will need it to do some further testing. And I had some idea. There is a web application vulnerability that is called Open Redirect. It is actually very common and very simple. The simplest example is that we have the URL address in which we can pass the parameter with other URL address, and then we are redirected to that other URL. So I had an idea that perhaps the Google Chat application checks if the domain is chat.google.com only in the link. However, if a link on chat.google.com would redirect me to another domain, then perhaps it would not be checked. I decided to verify it. I opened Burp, the most popular web proxy. I enabled the intercepting. And then my idea and my way to check if that would work is to just go to the application, press refresh, and then the request is being caught by Burp. And what I can do now is that I can just intercept the response to this request. OK? And when I do this, I'm getting the response, 200 OK. And I am just going to change the type of the response from 200 to 302. And then I'm going to say that it should redirect to securac.pl. So what happens right now is this is a response from chat.google.com domain that would redirect to another domain. And what was interesting is that redirect opened in the desktop application. So this is exactly what I wanted to achieve, because it proves that I am able to redirect user from chat.google.com to another domain. And because there are no address bar in here, you are not able to tell if you are on a malicious domain or a legit one. So I needed to find the open redirect in chat.google.com domain. And it proved to be much easier than I initially thought. Because if I have the host chat.google.com and I'm trying to go to any URL that starts with /account/, it gets redirected to accounts.google.com. So I am able to get out from the chat.google.com domain to accounts.google.com domain. This is not what I wanted to achieve so far, because I wanted to go to arbitrary domain. But this was a good first step, because at this point, I decided to be a little bit like a script kiddie. So I just Googled if there are any known open redirects in accounts.google.com domain. And amazingly, there was. From 2016, a well-known Google Open URL redirection. And this is a wagmore.eu blog. And here we have a URL to accounts.google.com that, with some steps in between, redirects the user to the wagmore.eu domain. So let's try it. So I opened the chat application. And I am just pasting a link that I prepared earlier. So here I have the link to chat.google.com/accounts. So it would get redirected to accounts.google.com. Then it would get redirected to app-engine.google.com. And then it redirects to bentkowski.info, my own domain. So the idea is that we send that link to some user we don't like, or some user we want to get his Google credentials from. And he presses that link. And then, oh my God, I need to log into Google again. Damn it. However, this is actually not a real logon page to Google. This is a logon page that is hosted from my own domain. And there is absolutely no way for you to tell that this domain is fake, because there is no address bar, so you have no way to do that. Let's try to do the same thing in the web application. So I will go to the web application, I will refresh the page. It would take a little while. And then I'm pressing that link again. And when I do it, of course, exactly the same page is being opened. So there's the fake logon page that is hosted on my domain. However, we can look at the address bar. And in the address bar, we clearly see that this is not the legit domain. So, of course, it doesn't work for all users, because something like phishing actually works and works pretty well in real life. However, the address bar at least gives us a way to check if that domain is okay, if we can trust that domain. And this was the first bug, actually, in the Google Hangouts chat application, so that I am able to redirect user to my own domain. I am able to steal his or her credentials. However, if you pay attention, then you might notice that so far I haven't said a single word about XSSs, while the topic of the presentation is magic of XSS. So where is the magic of XSS? So we're going to go to that. The Hangouts chat application is written in Electron. So I'm just going to write a simple Electron application. I am going to do some git clone. Then I am going to cd to that, install all the dependencies with npm, which of course needs to download many packages, 145. And then I can check the sources of that page. This is something like a hello world to Electron. And this is a very simple application. We have the HTML, we have some JavaScript, so this could be a web application as well. However, the difference between JavaScript in web applications and the JavaScript in Electron is that we can use Node.js modules in here. So as you can see, I am trying to access some Node.js variables, like process.versions.node, and at the bottom I'm trying to require some module. And if I open the application, so just npm start, then as you can see, I am getting a desktop application that looks like a web application, but I am able to access Node.js modules. So what I can also do, and I'm going to show it, is that I can require, for instance, the module that is called child process. So I'm going to require child process. And with child process, I am able to execute arbitrary shell commands. So I am just going to show you that it works. I will execute that command and write in the response the output from that command. And when I try to start it, you can see that the ID shell command actually executed, and I can see the result. So this proves that I am able to execute arbitrary commands with JavaScript in Electron. But life would be too easy if that would always work. Because if we have a look at the main file of the Electron application, we can see an object that is called web preferences. And it has a variable that is called node integration. And node integration by default is equal to true. However, many real-life applications actually change it to false. So when I change it to false, I am no longer able to access the node modules. We can see that. I will just try to run the application again. And when I do this again, as you can see, there is no result of AD anymore. And I didn't find a way to bypass it. I didn't find a way to bypass the missing node integration. However, sometime after publishing in my blog the information about this bug, another guy that is called Matt Austin, he has some amazing research on Electron applications and other technologies that works in a similar way. He tweeted that he found a path to full remote code execution in that Google Hangouts chat application. And what was interesting is that he didn't find a security issue in Hangouts chat. He actually found a security issue in Electron itself. So what was the issue? If I don't have the node integration turned on, I cannot access the following with JavaScript. I cannot require child process because the function required is then not defined. However, I can run a new about blank window. It worked for some reason. Opening any other window wouldn't work, but opening this window worked. That was interesting. And that window, of course, didn't have the node integration set to true. However, and this is pretty funny, when you open another window from that about blank, the second window opens with node integration set to true by default. This was actually a security issue in Electron, and it was possible to bypass all the secure web preferences that you set before. So let's check it. I'm going to modify the earlier example a little bit. So I'm going to add some script. I need to open the about blank window, which also works if I pass an empty script, an empty string. And then I'm going to do the second open. At first, I'm going to include the child process module. And then I can just run what we usually run when we want to prove the remote code execution on computer or end user computer, is that I open the calculator. So I will open the calculator. That will be the proof that it works. I also try to execute the ID function and to alert its result. And then I just need to close the script. And the scenario of the attack is exactly the same as before. I just need to send my victim a link that points to my domain. And on my domain, there's my own JavaScript code that will actually execute arbitrary commands on the computer of my victim. Let's check it. So I'm going to save it in Vim, then run the application again. And I just realized that there is some information disclosure in the background of files on my server, but never mind. And so we just send the victim the link, and the victim just needs to click that link, and bam, calculator opens, the other command opens. So I am actually able to execute arbitrary commands on end user computer, abusing the fact that I was able to redirect him or her to my own domain. So as you can see, Electron is pretty popular because it makes it possible to write desktop applications using the same technologies that we use in web. So HTML, JavaScript, and CSS. However, this creates a new attack surface. So because of the missing address bar, we are able to make phishing much more believable. And also, cross-site scripting in many ways could be easily transformed to remote code execution. I will check if there are any questions at this point. OK, no questions. Perhaps they are moderated. OK, so I will just leave it for a while, because I am pretty quick on time. So I'm just going to show you another interesting security issue that is pretty fresh that I found in Google Chrome Canary. I have shown it yesterday in the community corner, but I have some time, so I can show it again. And this is a security issue that I found in a new HTML element that is called portal. Does anyone know what portal is or heard about the portals? I cannot see, I guess, anyone. OK, so I will going to show you what portal is, and then what you can do with a portal. So give me a second. OK, so basically, I can create a portal that points to some domain, like securitum.pl. And when I open the page, okay, it works very similar to iframes. As you can see, the securitum.pl web page was just embedded within the page. So this is something like iframes. So the question is, what are the differences between portals and iframes? And there are a few significant differences. And the first one is that you cannot access the DOM tree of a portal. So you don't have content window or content document as in portals, as in iframes. In Portal, you cannot do that. The only way to communicate with the embedded content is to use the post message, so using the asynchronous communication. However, the main feature of Portal is that a portal, oops, some spoiler, that portal you can activate. And when you activate the portal, there's something that is pretty unique that happens that you were not able to do before, is that the portal suddenly becomes the top frame. So it is not re-rendered, it just jumps from being in a portal to being a top frame. And there is an interesting example in the official documentation of portals I'm going to show you, that if I try to open some page in Portal, like securitum.pl, it that opens in the bottom part of the page, and when I click it, you can see that it immediately goes as a top frame. This is the pretty unique feature of portals. Okay, so I had prepared a page that is called Portal Playground. I'm going to show it. Okay. So here I can input some address like securitum.pl, and then the same address is being opened in Portal and an iframe, so that I can see what are the differences. And as you can see, the page didn't open in iframe, but did open in Portal. This happens because Portal ignores the XFrame options header. So you can open anything in Portal, whether it has XFrame options turned on or off. It doesn't matter. What is also interesting is that generally, you are not able from HTTP to open file URLs in portals, in iframes. However, it works with portals. As you can see, I am on HTTP address, and I am able to open file. That is pretty interesting. What is even more interesting is that I am able to open the Chrome URLs. So for instance, Chrome version, and it also opens here. Just everything opens here, in fact. And that made me wonder. Let's say that I open accounts Google.com in Portal. So basically, when you open something in Portal and you input some address to Portal, you are just able to do exactly the same things that you are able to do in the address bar. So in the address bar, you can open file, and you can open file in Portal. In the address bar, you can open Chrome, you can open Chrome in portals. So what you can also do in address bar is that you can run arbitrary JavaScript. And then this JavaScript is run in the domain on which I am currently on, so accounts Google.com in this instance. So what would be interesting is to find out if I am able to execute JavaScript code in Portal. So I didn't get anything, the alert didn't fire. However, this happens because the alert is not allowed to escape the portal. I can try to execute console log, for instance, and as you can see, the console log executed. The question that remains is in what domain this console log executed. And when I try to console log document domain, we can find out that it actually executed in domain accounts Google.com, which means that it is actually a same origin policy bypass. So bypass of the most important security principle in browsers. So I am able to execute JavaScript in any domain. So I can steal data from any domain. And what is also more interesting is that I have a button here, steal HTML from Portal. This is a bug in Chrome that is already fixed, by the way. And I am just able to steal any data from, as you can see, accounts.google.com. But I am not only able to steal data from other domains, I can also run the file protocol. And then when I try to steal HTML, I can also steal the file contents. So this was a bug that made it possible to bypass same origin policy, as well as to read arbitrary files on the disk of the user. And this was a bug that I reported like 3 weeks ago to Google, and it was already fixed, and it was given a pretty nice bounty because it was $10,000. But this is not all what is interesting with portals. Because as I said, Portal ignores X-frame options. So there is an interesting attack that you can do with portals that wouldn't work with iframes. It is called Captcha. Okay, so imagine that you go to some page and you see something like that. Please enter the Captcha below. Well, this looks pretty annoying. The Captcha is pretty long, but well, they want me to enter that Captcha, so I will do that. However, actually, there is a portal embedded in here. And what this portal shows is my API key to Shodan. So I am able to embed the API key, and I just ask someone nicely, hey, please re-enter your API key for something, because you are not able to tell if this is API key or this is a regular Captcha. I'm going to reset the key because there are some cameras going on, so, so that it wouldn't work anymore. So as you can see, this is an attack you cannot protect from with portals because it ignores the X-frame options, so you just cannot do anything. This is pretty nice or pretty bad, depending on which side you are in. OK. I'm going to show you 2 more quite funny things, because I still have some time. I will use Portal to do port scanning. This is pretty unexpected, but this is pretty amazing. I just couldn't believe it when I have seen that this is actually reliable and it actually works. So I'm going to open the Portal playground. And a portal fires the onload event when the page is loaded. So I just console log it. I am console log how many times the onload event has been fired. And what is interesting is that basically in browser, I can access some non-HTTP ports. For instance, I can access the port 3306. And when I do it, of course, Chrome wouldn't display anything because this is not HTTP, this is MySQL, but it says that this is invalid HTTP response. When I try to access, for instance, 3307, then we have connection refused, which means that the port is closed. When I go to 3308, the port is filtered on the firewall, it is dropped, so I won't get any answer in a while. So let's check it in Portal. What happens in Portal? So I try to open in Portal security on home PL 3306, and the onload event fires 4 times. This means that the port is open. It can fire another few times, but generally the number is even. However, when I try to open a port that is closed, like 3307, then the event fires 3 times. Not 2, not 4, but 3. So as you can see, I am able to tell what is the state of the port, basic it on the number of how many times the onload event fired. I couldn't believe that it's actually repeatable and it always happens the same way. I have no idea why it fires 3 times or 2 times, but it works every single time. I'm going to show you a page that is called port scan. and I defined a method that is called scan port, and I will try to scan 3306. Oh, this is a promise, so I need to await. So unload fired 4 times, so it means that the port 3306 is open. Unload fired 5 times, so this means that the port 3307 is closed. When I try to 3308, well, unload didn't fire at all in some timeout, so I guess that the port is filtered. And if I opened Nmap, I would get exactly the same result. So who needs Nmap when you have the web browser? And the last funny thing I'm going to show you is downloading things. I will just close it and make it a little bit smaller. Okay. When you try to download a file in Chrome or Chromium, it gets downloaded automatically, and in the bottom bar, you get information about the file name. So in this instance, this is test.txt. When you try to download many files, so the page, for instance, try to have some set interval and try to download it many times, then the browser blocks it, and I need to specifically allow the page to download many files. So most users wouldn't probably do that. However, when I try to go to a page that downloads a file in a portal, then the file gets downloaded as well. However, I am trying to do something like here, download HTML, is that I am just trying to download a file in portal every 200 milliseconds. And when I press the try to download many files using portal, as you can see, the protection doesn't work anymore. So I can just fill up the empty space of disk of the user in a very quick and simple way. Okay, maybe I will stop it. Okay, so this is a short summary of a security analysis that I did of the portal element. As you can see, it is pretty interesting, and I can convince you to analyze it even more, because if you look at the specification of portals, I'm going to show you. Oh, this is not the portal I meant. Okay. And every single specification in web has a section that is called security considerations. Let's see the security considerations of portal. Well, there aren't any, so maybe it is us who should look at the security considerations of portal. Okay, so that's it. I will check if any questions showed up. If not, then there are probably some technical problems. So if you have any questions, you can just come by and ask me the question in person. Thank you very much for your attention, and